All right, continuing section 5.1, I hope that you took time to write down examples 2 and 3 from the notes and solve those on your own. If you haven't already, why don't you take a moment to do that before you watch the solution. So in example 2, we have a really easy problem because we just need to get rid of the numeric coefficient of y here. So we're going to be multiplying by its new reciprocal, the 3 here, its reciprocal is 1/3, which on this side I'm going to show that as looking like division because it is. So now I'm going to have my new equation as y is equal to 6 divided by 3, which simplifies to 2 times x, minus 4/3. And from there, we can of course write the slope and the y-intercept, remembering that the slope is the numeric coefficient of the x, so our slope is 2, and our y-intercept, which we usually write as an ordered pair, is 0 for the x-coordinate, and whatever the constant is with its sign is a negative 4/3 this time, and that's our y-intercept, 0, negative 4/3. In our your turn example, example number 3, we have more complicated, kind of like the first example I did for you. First of all, we need to move this 2x to be with the constant term. So I'm going to add its opposite. Remember, it's being added to the 3y, and so we need to add its opposite to both sides in order to make it magically disappear. So 3y is equal to negative 2x and then plus 9. And then last but not least, multiplying by the reciprocal of the numeric coefficient of the y, and I'm going to show that as division because it actually is division. Multiplying by reciprocal is division. And now I have that y is equal to negative 2/3. That doesn't simplify at all, so I'm just going to write it as negative 2/3 times x, and then plus 9 divided by 3, which is 3. And then remembering that the slope, the m, is the numeric coefficient of the x, so that's a negative 2/3, and my y-intercept, which we usually write as an ordered pair where the x equals 0, and the y is the constant, and my constant in this particular instance is a 3. And so there's our slope and y-intercept. All right, now moving on to our next examples. What we have is finding the solution from the general form. So what we're prepping to do in this particular instance is to find solutions, and knowing that every x and every y will eventually be part of a solution for a linear equation in 2 variables helps us out because it allows us to choose either an x value and then solve for y, or choose a y value and then solve for an x. And the one that we choose to plug in for is totally up to us, and we usually choose the one that's quote unquote easier. So we're going to go ahead and we're going to find some solutions for these. All right, so here's example 4. The first thing that we're going to do is we're going to choose a variable to substitute in for. Because x has a numeric coefficient of 1, it's much easier to substitute in for the y and then solve based upon that. So remember, I can let y equal anything under the sun because eventually every single value of y will be part of a solution. So I'm just going to randomly choose a number. You could randomly choose a number and it's going to work. So I'm going to let y equal 1. So x minus 3 times 1 is equal to 7. Now once I've substituted in, my next step is to go ahead and solve this. So I simplify. So this simplifies 3 times 1, which is 3. And then this says x minus 3. So I'm going to add the opposite of a negative 3 to both sides in order to finish solving this problem for x. And now maybe you see why I chose x to solve for, because once I do that addition property, I have my solution for what x is. X is equal to 4. And then finally, with my x and with my y, I form an ordered pair. So x is equal to 4 and y is equal to 1. And we can always check this to see if it satisfies by plugging it back into the original equation. Does 4 minus 3 times 1, which is 3, does this equal to 7? And we have, no, it doesn't, because look, I made a mistake. 7 plus 3 is equal to 10. So x is not 4, x is equal to 10. There's your value in checking these things. So what we see is checking